Hi children, welcome back to the online classes. This is the third session for the chapter reflection of light at curved surfaces. Reflection of light at curved surfaces. So, in the previous session we have drawn the ray diagram for the image of the candle. So, let us draw the ray diagram for the objects which are kept at different distances. So, ray diagrams. So, in this lesson we will learn, in this class we will learn about ray diagrams. So, ray diagrams. So, first case, when the object is beyond center of curvature, let us change the distance of the object and try to draw the ray diagrams of that. So, first where the object was kept, object is beyond center of curvature. So, consider a concave mirror. So, the center of curvature is C and the line joining the pole and the center of curvature is the principal axis C, and you has to follow the rule. The focus point should be between the midpoint of P and C. So, this is the principal axis. So, what is the first case? When the object is beyond center of curvature, beyond means in this direction. So, the object was located here, where the image will be formed. So, to draw the ray diagrams, select the tip of the object, and draw a light ray parallel to the principal axis. This light ray will passes through the focus point and draw another light ray passing through the focus point, and the reflected light ray will be like this. So, this is the image. So, here we will get a formation of image. So, you will get the formation of image like here. What is the nature of the image? So, nature of the image is diminished. It is a diminished image. The actual size, if you use the scale to draw this diagram, you will get a smaller size. Here I was drawn with small defect. You has to draw the ray diagrams with your scale only. So, if you didn't use the scale, you will get some defects in the ray diagram. So, it is a diminished, inverted, real image. This is the nature of the image. So, remember that when the real light rays are intersected, really light rays are reflected and intersected here. That is why we will call this as real image, or this image cannot be viewed with your eyes. It can be projected on the screen only. Such images are called real images. So, when the object is placed beyond center of curvature, the image is obtained between focus point and center of curvature. What is the nature of the image? What is the character of the image? It is diminished. Diminished means smaller than the object. Diminished, inverted and real. And change the position of the object. When the object is, we will move the object like this. When the object is beyond center of curvature, the image was formed like this. Now, keep the object here. That means at the center of curvature. So, when the object is placed at center of curvature, let us see how will be the ray diagram. When the object is at center of curvature, now where you have placed the object? At the center of curvature. So, again concave mirror, the midpoint of the mirror is the pole P, and this is the center of curvature of this mirror. Exactly at the midpoint of pole and center of curvature, focus will be located. This is focus point F. This is the principal axis. And where you have placed the object now? You have placed the object at the center of curvature. So, be cautious that you need to draw the ray diagrams with the scale only. Exactly, you need to draw a parallel line. This is the parallel line to the principal axis. Draw a parallel line to the principal axis. So, if it is not parallel, you will get a wrong ray diagram. Parallel light ray, a parallel light ray. So, if it is parallel to the principal axis, then the reflected light ray will pass us through the focus point, You need to use the scale, otherwise you will get incorrect diagrams. So, this is the reflected ray. Another light ray, consider another light ray passing through the focus point, So, the light ray passing through the focus point, if the light ray passes through the focus point, the reflected ray will be parallel to the principal axis. If the light ray is passing through the focus point, the reflected ray will be parallel to the principal axis. If you observe here, the image will be observed exactly at the center of curvature only. The image will be observed at the center of curvature only, and it is of same size. What is the nature? Same size. Here also the direction of the image will be reversed. That is why inverted, and it is a real image. So, now bring this object in between focus and center of curvature. Now, you have placed the object initially beyond center of curvature, later you have placed at center of curvature, and now place the object in between focus and center of curvature. So, that is the another case. So, third one, when the object is placed in between focus point F and center of curvature C. So, let us see how will be the ray diagram, and let us see how will be the image formation. So, this is the concave mirror, pole, midpoint of the mirror, center of curvature C. The line joining the pole and the center of curvature is principal axis. The midpoint of pole and center of curvature is focus point F. Now, you have placed a object in between focus point F and C. Now, let us observe. So, consider a light ray parallel to the principal axis. This light ray will pass us through the focus point, and consider another light ray passing through the focus point. So, here the image will be observed beyond center of curvature. And it is larger size. Indeed, the size of the image is larger. That is why the nature is, if it is smaller, we will call it as diminished. If the size of the image is larger, we will call that as magnified or enlarged. Enlarged image means this is the actual size of the object, but we have got a larger size of the image. So, magnified or enlarged image will be observed, and it is a real and inverted image. Real and inverted image will be observed. When the object is placed between focus and center of curvature, the image observed is magnified, real and inverted. So, let us consider another case. When the object is placed between, now place the object between pole and focus point P and focus point F. So, when you place the object in between pole and focus point F, let us see what happens. So, this is the concave mirror. The midpoint of the mirror is the pole. This is the center of curvature C. The line joining the center of curvature and the pole is the principal axis. You have to locate the focus point at the middle P, C, F, and you have placed the object here. You have placed the object here. Now, consider a light ray parallel to the principal axis. Consider a light ray parallel to the principal. How this will be reflected? The reflected light ray will be like this. The reflected ray passes through the focus point. The reflected ray passes through the focus point. Now, consider another light ray. Consider another light ray which is passing through the center of curvature. You can consider that light ray. So, here this is the light ray which appears to be coming from the center of curvature. So, this light ray will reflected in the same direction, So, it is incidented along the normal direction. This light ray is incident along the normal direction, it will be reflected. If you observe, these two light rays are diverging. Diverging means moving away from each other. This is the center of curvature C. If you consider a light ray passing through the center of curvature, it will incident on the mirror and reflects back. If you observe, these two light rays are moving away from each other. So, if you extend the light rays in this direction, these two light rays will intersect here and forms a very magnified image. So, this concave mirror, when the object is placed between pole and focus point, a enlarged image, a magnified image it will be observed. A magnified image, and it is a virtual image. What is meant by real image? If you project it on the screen, it is a real image. If you cannot project on the screen, only you can view with your eyes, then it is a virtual image. And it is an upright image. It is not inverted. What is the direction of the object? It is also in the same direction. So, that is why it is magnified, virtual and upright. Virtual means not real. So, for example, if you observe the image of you in the mirror, is it real? Are you really there? No, it is a virtual image. You can view with your eyes only. You cannot project it on the screen. Such images are called virtual images. If you want to observe this real image, you have to place a screen. You have to place a white screen here. Then it will be observed. Otherwise, you cannot observe the real image. Such images are called real images. So, for this image, you have to view with your eyes only. So, in this way, the concave mirror. So, these are the ray diagrams of concave mirror. So, when the object is placed in between pole and focus, you will get a magnified image. This property of concave mirrors is used in the application of dentists. Dentists will use this. Dentist shaving creams, shaving mirrors will be uses this concave mirror. So, if you went to a dental checkup, what they will do they will do a concave mirror shaped substance will be placed in our mouth. So, it is a concave mirror. The mirror that dentists will use is a concave mirror. Why? Because if the distance is very less, it will form a magnified image. And also concave mirrors are also used in making solar cookers. Why? Because when light rays are incident on a concave mirror, these light rays are focused to a single point. These reflected light rays will focus to a single point. So, if you create a utensil here, if you place a utensil here, what will happen? That utensil will heats up. So, in this way the light energy will be used by the concave mirrors. That is why you can use the concave mirrors for making solar cookers also. So, let us discuss about, so till now we have discussed about ray diagrams of concave mirror. Now, let us see the ray diagrams of a convex mirror. It is very easier than the concave. So, now we will try to draw the ray diagrams of convex mirror. Convex mirror. So, consider a convex mirror. Consider a convex mirror. So, this is the midpoint of the mirror and this is the center of curvature C. The line joining the center of curvature and the pole is the principal axis. Exactly at the middle focus point will be there F, and let us consider, so you cannot place the object in this side. Why? Because this is the reflecting surface, you have to place the object here only. So, place the object here. So, I have placed an object here. Now, consider a light ray parallel to the principal axis. This is the light ray parallel to the principal axis. When the light ray is parallel to the principal axis, so the reflected light ray will be appears to be coming from the focus point. The reflected light ray will be appears to be coming from a focus point. Now, let us consider another light ray. So, which is passing through the focus. So, not like this. So, consider a light ray. So, here the reflected light ray will be. So, here I have considered a light ray which is passing through the focus point. The reflected light ray will be parallel to the principal axis. If you extend this reflected light ray, here this is the point where you can obtain the image. So, I have considered a light ray which is passing through the focus point, So, how this light ray will be reflected? So, it will reflect parallel to the principal axis. So, extend this reflected light ray, you can get the image. So, in this way, wherever the object is placed, you will get the image in between focus and pole. So, wherever the object you are placing, you will get the image at focus and pole, in between focus and pole only. So, that is why this convex mirror is used in vehicles. Wherever the object is. So, even the object is at large distance, the object image will be obtained in between focus point F and pole. So, whatever the object distance, you can get the image in between focus and pole. So, you can get the nearest image. That is why you will find that in the mirrors used in the vehicles, the images appeared in the mirror appears to be closer than the actual. So, what is something will be written under the mirrors of the vehicles. What it will return? The images in the objects in the mirror appears to be closer than their actual distance, right? So, because of this reason. So, here I have drawn the reflected rays. You have to extend the reflected rays to get the image of the object, So, wherever the object is placed, the image will be observed in between focus point F and pole. So, there is only one ray diagram for the convex mirror. Why? Because whatever the object distance, the ray diagram will be similar to like this. So, the image distance does not changes, the image between is in between focus and pole only. So, that is why there is only one ray diagram for convex mirror. So, now let us learn about mirror formula. Let us learn about mirror formula. So, what is mirror formula? In the case of concave mirrors, we have drawn the ray diagrams for the concave mirror. For different object distances, we are getting the image at different distances. So, what is the relation between image and object distance? What is the relation between image and object distance? That relation will be given by this formula. So, let us look into that. So, let us consider a concave mirror. So, let us consider a concave mirror. So, this is the center of the mirror pole, this is the center of curvature of the curved surface, this is C, this is focus point capital F, and consider an object here, and let us consider a light ray which is parallel to the principal axis. So, this light ray will be reflected in such a way that it passes through the focus point. Now, consider another light ray which is passing through the focus point. So, this is the another light ray. So, you will get a image here. This is the image. So, let us say the image as, so in order to derive the equation, let us denote the points as, let us denote the object as O prime. I was denoting the point, this is O prime, image I prime, Let us denote this point as M, and let us denote this point as N. So, this point as N, this point as M. So, from this you can observe the two triangles. I will say the two triangles PNF and FO prime. Can I say those two triangles are similar? Yes, when you will say here triangles PNF and FO prime are similar triangles, So, when you will say the triangles are similar, if two angles are equal, then you can say that the triangles are similar. Here this angle and this angle are similar. So, just imagine this as a straight line. So, this angle 90, this angle will be 90. So, in that way these two triangles PNF and FO prime will be considered as similar triangles. So, if two triangles are similar, so from figure PNF and FO prime are similar triangles. If two triangles are similar, then the ratios of their sides are similar. So, let us find out the ratio O prime by PN. O prime by Pn is equal to, we have taken the side first here, O prime by Pn is equal to FO by PF. What I have taken, this is one of the side for this triangle. O prime is the side of this triangle. FO prime, this is one of the side of this triangle. Pn, this is the one of the side of this triangle. We are taking the ratios of the triangles. If the triangles are similar, then the ratios of their sides are equal. Here I have considered the ratios of their sides. If you observe from here, Pn is equal to I prime. This is in the shape of rectangular. Approximately this is in the shape of rectangular. So that's why in the place of, so from figure, Pn is equal to I prime. From figure, Pn is equal to I prime. So substitute O prime by I prime is equal to FO. What is PF? PF is the focal length. Just reminds PF is the focal length. So place the F in the place of PF. PF is the focal length, and let us say the object distance as U. Where the object is located? Here. So the distance between the pole and the object is U, and let us consider the image distance. So this is the image distance, this is the image formed. So this is the pole. So this distance is V. Here FO. So here PO is the object distance. So you can write PO is equal to PF plus FO. You can write PO as PF plus FO, right? PO is equal to PF plus FO. So what is PO? This is the object distance. You have taken U. Object distance U. What is PF? Focal length small f plus FO. So bring this small f to this side. FO is equal to U minus F. So in the place of FO, you can substitute U minus F. So let us consider another two triangles. So now from figure the triangles FI prime and PFM are the similar triangles. How you have to identify the similar triangles? Why? Because here this angle are equal, and here 90 degrees. If two angles are equal, automatically the third angle will also be equal. So these two triangles can be considered as similar triangles. So if two triangles are similar, then the ratios of their sides. So let us take the ratio I prime or PM. So PM, this is one of the side, PM by I prime. This is one side of the triangle, this is one side of the other triangle. So I was taking the ratios of the sides. So this is the rule, mathematical rule. If two triangles are similar, then the ratios of the sides are equal. So PM by I prime is equal to PF by Fi. This is one side, this is another side. So Fi. So here you can observe Fi. We need to know what is Fi. So to know that what is Pi? Pi is the image distance. So Pi is equal to PF plus Fi. PF plus Fi. We need to know about this Fi. Here we have written Fi. So find out that what is Pi? Pi is the image distance, and we said that as V is equal to PF means focal length small f plus Fi. So we need to calculate this Fi. So Fi is equal to V minus F. Fi is equal to V minus F. So in the place of PF, what is PF? PF is the focal length small f and Fy, what we have got, Fy is equal to V minus F, Fy is equal to V minus F. So, if you observe here, Pm is the same as OO prime, Pm is same as OO prime. So, in the place of Pm, substitute OO prime by I prime. Here you have got two equations, this is equation 1, this is equation 2. If you observe the both equations, the left hand side of these equations are same, OO prime by I prime is equal to OO prime by I prime. So, if the two left hand sides are equal, you can equate the right hand sides of the equation. So, equate the right hand sides of the equation. Why? Because their left hand sides are equal. So, you can equate these two. So, what are the right hand side terms? U minus F by F is equal to F by V minus F. Let us cross multiply this equation. So, if you cross multiply, U minus F into V minus F is equal to F into F, F square. So, let us multiply this, U into V, UV, U into minus F, minus UF, minus into V, minus F into V, minus FV, minus into minus plus, F into F, F square is equal to F square. So, here F square gets cancelled and bring these negative terms to that side, UV is equal to UF plus FV. Now, divide the complete equation with U into V into F. So, with this the equation was completed. So, to remember, to get a simplification, divide this complete equation with this term. So, if you divide the complete equation, UV by UVF is equal, I was dividing this complete equation with this term. So, UF by UVF plus FV by UVF. So, what we can say, UV, UV, UF, UF, FV, VF cancel. So, what remains here, 1 by F is equal to 1 by V plus 1 by U remains here, 1 by U. So, this is what we call as mirror formula. This is mirror formula, 1 by F is equal to 1 by V plus 1 by U. So, with this you can relate the image distance and object distance. This is the relation between image distance and object distance. So, with this session is completed. Thank you.